So we have three ways to measure an angle. Really, two that we're talking about. We got degrees, we got radians, and you can think of it as rotation if you want, right? One rotation is equal to 2 pi radians is equal to one rotation is 2 pi radians is 360 degrees. All right, so what would a third of a full rotation be? A third of a full rotation, so that would be 120 degrees, right? That would put you like, there's 90, so that's a third of a rotation. So it's 120 degrees in degrees. It's a third of a rotation. What would that be in radians? Well, you're just dividing this by 3, right? So you divide this by 3 and you get 2 pi over 3. Or use my conversion factor that I introduced, and if you realize it's 120, you multiply by pi over 180, and that should give you the same thing. So the degrees cancel out. 12 over 18 is 2 over 3. Okay, and I would read this 2 pi over 3. Not really 2/3 pi. Usually we say 2 pi over 3, which is the same thing. Here's a math textbook of conversion. I like to have kind of my own way, or what's easier. You just multiply by either this or this, whatever's appropriate, right? You don't have to, I don't like memorizing things. I don't like saying when I'm multiplying from degrees to radians, I multiply by pi over 180. I just do what makes sense, right? 120 degrees times what? Well, I got to put the 180 in the bottom because that cancels out my degrees and the pi up here. And this one we just did, 2 pi over 3. If I want 5 pi over 6, where is that? Well, I would have to put the pi down here and the 180 up here. Right, and then my pi's cancel out, and then I just take 5/6 of 180. If you need to do a little bit of thinking, you can say, well, how many times does 6 go into 180? That's 30. So that's 130. Whoops. See if I can multiply correctly. That's 150 degrees. Okay, and again, start thinking about these. 5 pi over 6, 150. Same thing. 120 degrees. 2 pi over 3. Eventually, soon, I just want you to be thinking about radians. We'll use radians a lot more than degrees going forward. And then when you get to calculus especially. Okay? So I want you to be familiar with these, just as familiar with 2 pi over 3 as you are with 120 degrees. All right, let's do a couple more. See if you can get these. Pause the video, see what you get. Negative 7 pi over 6 times pi 180, 130. That should be negative 210 degrees. 720, our first angle over 360. That's 2 rotations. So that should just be 4 pi. Let's see if it works out. 180, 2 pi. Whoops. Pi over 180. 180 goes into 724 times, so that's 4 pi. 4 times, so that's 4 times pi. Okay, now, trigonometry. Trig, don't be scared of trig. Trig, the basic trig definitions are really simple. They're just fractions. All right, so I have this circle here. We're just going to fix it at radius 1. So it would be this is the point 0, 1. This has to be the point on the xy plane 1, 0, negative 1, 0, and so on, 0, negative 1. Radius 1. So if I pick any point on this circle, xy, and make a triangle. Okay, so I got two things going on here. I got a circle and a triangle. So that's a right triangle. Okay, and then we have a couple definitions to think of. I got the terms I'm going to use: opposite, adjacent, and hypotenuse. You've heard hypotenuse. This is the hypotenuse. Okay, and then in relation to this angle theta, central angle, this side would be opposite because it's opposite the angle, and this side would be the adjacent side, right? It's adjacent to the angle, kind of like next to the angle, but not the hypotenuse. Okay, and those are important because that's how I'm going to define my sine function, my cosine function, and my tangent function. Okay, so we'll get there in a second. Notice that the triangle is inscribed in a circle radius 1. Such a circle with center at the origin and radius 1 is known as a unit circle. We'll talk about this later as well. Unit means one, circle means circle. Okay, so a circle with radius 1 centered here at the origin is called the unit circle. Alright, so if you take this triangle and you moved it around and maybe change, these distances can change as you move around. This is t or theta or alpha or gamma, whatever we want to call it. And then again, opposite, adjacent. I'm going to use this to define my trig functions. Okay, so let's talk about the sine function. Sine. What is sine? I'm going to abbreviate it. So sine of an angle. Should we stick with t? What do I have down here? Yeah, let's stick with t instead of theta. So sine of t, abbreviated sine t, or sine of t, not sin, sine of t, is equal to the opposite side divided by the hypotenuse. Opposite over hypotenuse. That's it. That's all the sine function is right now. It's just a fraction. It's the ratio of two sides of a right triangle. And we'll talk more about why this right triangle is like living in this circle. But for right now, we just need to focus on the triangle. Okay, the cosine of t, abbreviated cos t, but we say cosine of t is just this adjacent side. Just another fraction, another possible fraction. The adjacent side divided by the hypotenuse. And then the tangent would be the only function that doesn't involve the hypotenuse. That's going to be opposite over adjacent. Okay, so SOHCAHTOA. We can remember, say this over and over again a few times, and you'll remember SOHCAHTOA. SOHCAHTOA. I hope you remember those definitions. Okay. Now we can expand these definitions to any place in the xy plane. Okay. So right now on the unit circle, these will be, we have a fixed value for r. Okay, but I can have any circle where this is just r instead of 1. This could be 2 or 3 or 4 or 5. It's a pretty bad circle, but work with me here. Okay, if the radius here is r, then that means this is r. This is, what's the distance from here to here? That's just x, right? How far you are from here. This is my triangle now. And this would be y. Okay, so we'll extend these definitions to the xy plane when we're not in the unit circle and r is any value. And you can guess kind of what these definitions will become. I'm getting a little ahead of myself. If this is an angle, what's opposite over adjacent in this picture right here is just y over x. What's adjacent over hypotenuse, it's x over r. And then what's opposite over hypotenuse, y over r. Okay, so these definitions for just triangle, and these definitions we'll look at a little bit later when we have a circle centered at the origin and we want to use our definitions in the xy plane. Okay, so these definitions don't need a circle, don't need an xy plane. These, if we put our circle in the xy plane and have an xy and what we call a radius or a distance from the origin. Okay, let's do one. These are easy. Here's theta. Find some trig function values. What's the sine of theta? Opposite. I get two definitions now. Opposite over adjacent, or what I just told you, y over r, which we're not really using in this one because I'm not in the xy plane. So I'm going to stick with opposite over adjacent. Easy. Cosine theta. Adjacent. Sorry, let me say that again. I think I said that wrong. Sine is opposite over hypotenuse. opposite hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. Opposite over adjacent. Okay. If we have three functions, if you think about all the combinations we did, you might ask yourself, well, wait a minute. What if we put the hypotenuse on top? We never did. Hypotenuse over adjacent. Right? Or in other words, we can flip all these guys. Take the reciprocal of all these. And we get three more trig functions. So we got 6 basic trig functions. Sine, cosine, tangent. And we got some new guys. The cosecant, the secant, and the cotangent. And those are just the reciprocal functions. So reciprocal just means 1 over that function, or flip the fraction upside down. For example, if I have, let me show you what this 1 over thing's all about. The reciprocal of the sine function is the cosecant function. Okay, so that means if I want the cosecant function, for this problem here, I do 1 over the sine. That's what the definition tells me to do. 1 over the sine. The cosecant's 1 over the sine, which also means the sine's 1 over the cosecant, the reciprocals of each other. So what's 1 over 4/5? Well, that's just the reciprocal of 4/5. That's 5/4. So you don't actually need the 1 over thing here. You can just flip these guys upside down. Okay, a couple definitions we're working with. That means the secant is 5/3 in this example, and the cotangent is 3/4.